Hey guys, so today we're going to take a look at special cases with equations. So first I want you to stop the video and I'd like for you to copy this chart or this anchor chart that I created. So now that you have created or written this in your notes, let's talk about how to interpret this chart. So we're going to solve equations just like we normally do. First do the distributive, first clear any fractions or decimals. Next, do the distributive property. Next, combine like terms on each side. And lastly, isolate the variables using inverse operations. Now, we're going to take a look at the final step or the answer, and we have new ways to interpret that. So, for example, if I end up with one letter equal to one number, that equation has one solution, and that solution is 4. Now let's take a look at a second situation. Let's say I end up with two unequal numbers. -3 can never equal -6, so that equation has no solution, and your final answer to that equation is no solution. And now let's take a look at the third situation. Let's say we end up with one variable, the same variable on both sides, or the same number on both sides. You can even have the same expression on both sides. If I had 2x plus 6 equals 2x plus 6, this equation is said to have infinitely many solutions. And the answer to this, or the solution to this, is all real numbers. So let's see how this actually looks in practice. So first example, we have 4 times 8n minus 1. Oh, I'm sorry, I want to use x for that. 4 times 8x minus 1 equals 19 plus 32x. So the first thing I'm going to do is split my equation at the equal sign. I don't see any fractions or decimals. I do see the distributive property. So the first thing I'm going to do here is this right here. So 4 times 8x is 32x, and 4 times -1 is -4. Bring down your equals, 19 plus 32x. I do not notice like terms on each side, so now I'm going to start isolating the variable using inverse operations. I do see that I have variables on both sides, so I'm going to start by moving the 32x to the left side. So the opposite of plus 32x is minus 32x. And look at what happens. 32x minus 32x cancels on both sides, so I'm left with -4 equals 19. Can -4 ever equal 19? No. So if I look at my chart, I have two unequal numbers. So this equation has no solution. So not only is that how many solutions it has, that is the answer, no solution. Let's look at example 2. So next let's take a look at 8 times x minus 6 plus 58 equals 2 times 4x plus 5. Always split at the equal sign. So the first thing I notice is I don't have fractions or decimals, but I do see the distributive property here and here. So I'm going to go ahead and bring down my plus 58 and my equal sign just so I don't forget it. So I'm going to do 8 times 1x is 8x. 8 times -6 is -48. And now let's do the other side. 2 times 4x is 8x. And 2 times 5 is positive 10. Next, I do notice that I have like terms on the left-hand side. So I want to combine those like terms. So I get 8x, -48 plus 58 is a positive 10, equals 8x plus 10. Now, guys, I'm okay if you stop here. I notice the same expression on both sides, but I want you to see what happens when we work as far as we can work. So next, I'm going to isolate the variable. I do notice I have like terms on both sides, so I'm going to subtract 8x from both sides, minus 8x minus 8x. It does cancel on both sides, and I'm left with 10 equals 10. Well, if I look back at my chart, let's see, when I have two equal numbers, that's this right here, when I have two equal numbers, or the same thing on both sides, then I have infinitely many solutions. Some people will even say infinite solutions or many solutions, but I'm going to write the whole thing, infinitely many solutions. So that's how many solutions it has. What is the answer? What is the solution? Well, the answer is all real numbers. And the reason that is, every single number that we plug into that equation will make it true. That's why the solution is all real numbers. Now let's take a look at our final example. Number 3. We have 33 plus 6x equals 3 times -1 plus 5x. So I split it at the equal sign. I don't see any fractions or decimals. I do, however, see the distributive property, so I'm going to start with that. Let me bring all this other stuff down so I don't forget it. So 3 times -1 is -3. 3 times 5x is positive, same sign's positive, positive 15x. I do not see like terms on each side, but I do see that I have variables on both sides. So I'm going to start doing my inverse operations. The opposite of plus 15x is to subtract 15x from both sides. So that leaves me with 33. 6x minus 15x is -9x equals -3, and that canceled. So I still notice I need to isolate that variable. It's a plain old two-step equation like you're used to. So I'm going to subtract 33 from both sides. So we have -9x equals, these are the same signs, so I need to add those, -36. And again, I still need to isolate that variable. So the opposite of times -9 is to divide both sides by -9. So x equals +4. So looking back at our chart, if I have one letter equal to one number, like I do here, this equation has one solution. So if the question says, how many solutions does this equation have? It has one. That means there's one number that makes this equation true if you plug it back into it. So what's the answer, guys? Your one solution is x equals 4.